Happy Musings, happy Monday. Oops, I didn't mean to do that. Anyways, before we get too far, I wanted to comment that the credits for the loading screen said the same thing, survive, at the very end. It just flashed on the screen and like, I don't know. So I think that's just a new thing. Or like, I don't pay too much attention to the comments, but I mean, then I do. And then it's like, I have to remember if I. Oh, also, duh, 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 you might have just seen something pretty interesting. So we have this giant behemoth of a temple with trees that's going on, and yeah, well, that's good. I also built this. Let's go check that out real quick while we talk about this. So, anyways, it cycled through a few different comments that were interesting. Um, the last one was survive. And so it's like kind of like this ominous message, like, is that a threat or like, what are you gonna do? And I would totally mess with people, like just send a warden or like a army of wardens, just randomly, just to like, I mean, not really kill you, like they deal like no damage, but just to scare the crud out of you. But I'd put in a message saying, or April Fools. Oh my gosh, there's like so much potential for that. But you'd have to sign a something, which a lot of us, I don't know about you, we sign a lot of things and say, yeah, sure, whatever. But yeah, so this is taking a lot of diorite. Now, most of this is slabs. Slabs and hollow. I do have, I think the border is solid diorite blocks, but yeah, this already took a lot, like a whole inventory's worth of diorite, or even a couple. Because each one of these columns is 10 tall, so 40 for each of these of solid blocks. And then those are solid blocks up on top. And I'm thinking of making the whole, I want to say it's the apex, but I'll have to look up the actual name for that. I've got a few art history books lying around, but like Greek architecture, Etruscan, I want to say, some ancient civilizations. I mean, this is still pretty cool, and that's a project that I'm not completely shelving that, but I thought this just looked like a perfect place for a gigantic temple. So this might be like the commemorative like mausoleum. Um, is it ofrenda? I think for the Dia de los Muertos, it's the ofrenda where you make like an altar for your loved ones that have passed away, like your family, and I think it's actually just family. Now that I think about it, I don't know if they do one for friends, but either way, I'm doing one for friends and family that have passed. So, but that's all depressing and gloomy, and like if I was looking down from wherever, if there is an other place, I'd be like, yeah, go play, go have fun, go do the things, go do the learning, and therefore I wanted to talk about password crackers. So I was actually doing some programming, which I love, just getting in the zone, throw on some Hilltop hoods. I ended up like dancing quite a bit too, but like I was doing some Python programming using my free tutorial, which I really need to add that link and a description to these. So, but again, I say this a lot. By the time you see this, the majority of you, yeah, I'll have my stuff figured out. But the Python code. So I already have an existing encryption decryption algorithm with a very basic ROT13, which stands for rotation of 13 values or 13 letters. But I like to think of it as values because underneath every char or character is a numerical value. There's a number. And that's really important because then you can manipulate it. You can add a number to get the next one in line. And it's the ASCII, the ASCII table, that has all of the characters laid out. And I want to say there's multiple char sets. Like there's international standards for keyboard layouts and such, but for all American stuff, it's a very simple 26 character alphabet, lowercase, uppercase. I mean, and at the same time, as I talk about this, so this is red teaming. This is teaching how to hack very poorly. I mean, ROT13 is a very basic encryption algorithm, and I have that on there. And this thing that I'm working on is actually for work. It's for a presentation to the company to just be like, here's just a visual aid of how easy it is to crack a password. So, and most of you should be protected with multi-factor, at least on your main email. Well, really every email that you use, and you should keep control of all of your emails, because I have a few. I have quite a few. I've got a couple public-facing ones. I've got multiple personal ones, like, and they're all protected with MFA. So which, and even getting into passkeys too. Like that's like the next step. Passkeys use at least like the majority of them. I don't know. There could be different variations or whatnot, but in general, a passkey is the idea of using like a fingerprint comprised of information about your device, your network, all of the things that can't be fudged by some person impersonating you on the other side of the world. And that's what most cybercrime is. Like whether it's a intentionally malicious, like they're actually trying to steal your information and rob from you, or which I mean, no different than back in the West days when someone would rob a train at gunpoint. Possibly, I mean, no, it is different. It's a lot less deadly, but still, it's stealing. It's stealing from people that don't actually have all that much, and that's a big misconception. I've noticed people around the world seem to think that every average American just has it great and has all sorts of money. Now, and actually, it's funny because the people that are usually more susceptible to like, um, I don't know, that's not always the case, but like drunk computing, like people that are not in the best place in their lives, like clicking links and doing things like sketchy things. I don't know. So, but anyways, there are a lot of rich Americans, but either way, there's a lot more Americans that are being trained on how to detect cybercrime, report it, and prevent it. The best step is multi-factor. Protect everything with multi-factor, because then it has to be something tied to your phone or your email. And if your email is compromised, then someone on the other side of the world can still. That's if you have like a send me an email at this address, which is still stronger than nothing. But ultimately, your phone, and eventually, I think the way that the world's headed is to have one phone number, one person. That's it. And then you've got a fingerprint made of you in a international database, a worldwide database, and then boom. Now it sounds a little scarier than it is, but it's an idea for like including one person, one vote, and having. We don't need to go down that road though. The main thing was discussing Python code and an algorithm to crack passwords. So let's get back to that. I mean, the fingerprint thing, it's not that scary because I mean, there's the information's already out there. That's the way that the IP protocol works. Like, network traffic has to know what address to go to deliver a message or data or whatever. Like, and it has to have a return address if you're going to really interact with that resource. Now, there are ways to, that's why a lot of hacking is really spamming, um, where they just ask you to give you their phone number or like somehow circumnavigate the initial means of communication, and those can't be retraced. So, but I mean, they actually can, because even with Tor, onion routers, and all that, like it can be retraced so many steps, and then each hop along, like most hops are monitored, and yeah, so you just can't. It's too easy to monitor just about everything, and legal to monitor just about everything. Encrypted or no, I mean, you could be, anyways. Cracking passwords. So the algorithm that I'm working with, let's go ahead and, I don't know, sleep through the night. Sorry, we borrowed a bed. So what I have is the Route 13 encryption, which is basically very basic weak encryption, which you should never use. But it's where like an A would become an M, or I don't even know what the counterpart is. But then if you did it again, it would decrypt the message back to normal text, or plain text. So, but I took the concept of the two dictionaries that translate a letter to a number and a number to a letter. That way you can just kind of use that frame of control rather than what I'm doing with this approach, which is the ASCII table values. And I remember spending a lot of time doing this in, see, I did it in C++ for my security class, and I believe I did it in Java for something else, because I was trying to, I mean, it really was kind of like a password cracker. We were trying to find the target string, but I just don't think they use the terminology like nefarious sounding or anything. It's just like, guess the word. It's something innocent, but no. So anyways, the idea is to cycle it through. So you're going to use a while loop, like while not cracked, and it's good to throw a safety catch in there, like an index is less than a number. Because you don't want an infinite loop. I mean, it's very easy to do that right off the bat, cycling through all these values. And then the two main functions in Python that you need to know are ord and char. So ord gets, I'm gonna mess this up. Ord gets the number from a char or a character, so it gets the ASCII value for it, and then char or chr, so chur, gets it's the opposite. It gets the char from a number. So you feed char a number and it'll produce the char of that ASCII character. Whereas the ord is the, I don't know, like the coordinates of a number. I don't know. Just wait, how's that? Yeah. I mean, I'd almost like have to check it. It was working. Like I was like doing a compare and contrast thing, and like if it reached the target, it would print out cracked in all capital letters. Just oh, whoops. Just to signify that yes, you have now found the password. And the reason that the phone idea isn't that scary is because we already have a lot of our banking tied to that with, multi-factor with phones. And to where, and even then, I mean, I guess there is like a certain level of fraud, what have you. Like definitely leeway or leniency. But then they go and they investigate and they catch the people doing it. So, I don't know. That's like that whole thing. Like if you get caught shoplifting in the U.S., like, I mean, you could get away with it so many times, but then like eventually they catch you once it's over like a certain value. And even if not, like even if it's just a value of say $3 or $4, it could end up costing like close to 100. Like it's just that magnified, tenfold or even more. Like 300? I don't even know that. If it was $10, it would be tenfold. So, anyways, you get what I mean. It would be a lot more expensive. It'd be like 97. Now I'm really messing that up. I almost reached for my phone to do a calculator moment, but anyways, I don't even know what we're trying to accomplish here. So, oh, basically that's it. So you got to make a loop to build a string to compare to the actual target. And so, because this is actually like assuming that you already know, or I mean, because in the real world, you'd be guessing it against like, well, you'd be entering it into the thing, and then you'd have to figure out how to program all that and blah blah blah, which it's pretty easy to detect anymore. At the same time, don't do it. I mean, it's just not worth the risk. Like trying this on a live system, like that's why these password crackers are nice and harmless, and you can run them in the browser, and it doesn't really matter, and they're not going to get flagged for like anything illegal. It's just trying to match a string. So by counting up the things, although as I say that, if you have the large enough prime numbers, technically that's an illegal number. I think generally if you just have a bunch of those saved for their use in cybersecurity, like I think they would just look harder at you because again, everything encrypted or no, like they've got supercomputers running endlessly, just monitoring traffic and decrypting things. So which goes the same for, China constantly boasts about having these supercomputers. It's not that hard. You can watch a YouTube video on hacking. Like, but I mean, you can also watch an easier YouTube video on how to detect said hacking and, report it and blah, blah, blah. So, the global accountability. So anyways, back to the password cracking. So you got Ord getting the number and char getting the char from a number. Okay, it's hard to keep that straight. But anyways, you're basically running it through the loop and all of the single digit chances, and then that depends on your scope. If it's an alphanumeric, then you're feeding 0 through 9. And again, this is just single one, digit, one char, one character, or a length of 1, basically. And then you do the loop. And so depending on your scope, and since I wanted to do this for the presentation, I actually wanted to zero it in on alphanumeric and omit special chars, just to show like, okay, so that's how easy it was with just normal, and how quick it is too, because this is in real time in the browser, on some machine in France, like doing the code and game stuff, and like, and thank you, code and game, you're awesome. I used to do Twitch streaming where I do clashes of code. Might do that again, but my internet is horrible. Like, I'd have to set up a whole new system. So anyways, you loop through all the possibilities by increasing the number value. So right there, you have to get the number value for the range of 0 through 9, which is so much. It's like 30 something or something. And then, like the max, all of the human readable chars. And that's like leaving out spaces and carriage returns and all the weird chars, or the weird characters that you can have in computers. But all the, uh, so that's including all of the number key things like exclamation point, question mark, @ sign, all that. It's like 32 to 127, I think, was the total range of human readable. And that's leaving out the space. Or no, 33, because I think 32 is the space. And again, these are numbers that if you put in that number into either the char or the ORD function, and that's why I just like test it. Like, it doesn't matter which one does which. I know one does one and the other reverses it. So once you have that kind of logic, you have the function that you can call to be like, hey, what number is a letter A? Okay, I've got that number. And now add one. All right, what char is one more than A? Oh, it spits out B. Okay, is it B? No. And then it continues to guess and compare against the to be guessed and the guess. So I have a couple of string variables just to kind of like be descriptive of how, what do I even have up here? Sorry, now I'm all curious. I think, yeah, I just like dumped a bunch of random flotsam. So I'll take all that and go appropriate. Ah. Anyways, so, and it's a matter of loop. Now, the problem that I'm running into right now is how to do it, because you append, and then you cycle through every single one, and trying to do it without doing it, like, too many inside loops. Like, I suppose you could do it every inside loop for every length increase. But I don't want to do that because it's not that scalable. That's more like hard coding. Like, you end up with like 10 loops for a 10-digit password. I'm not against it. I mean, I remember this one time I hard coded a program. It took me like hours, if not, no, days, to finish writing this stuff. And then I realized, wait, I could just feed all these into a list and then construct the string that way, a more more elegant way, elegant way to construct a string. Should I be growing a lot more crops? This is kind of, I'm thinking maybe that's what we should do with our project. Let's go ahead and, I need some quartz, or sorry, diorite. I keep thinking this is quartz. And it looks like marble. This is a pretty nice, let's see, I got that. Got more. Yeah. Ooh, yeah, lots. So anyways, and I need the buckets. Let's actually now drop this flotsam down here. Wait. Definitely don't need all that. Alright. Just trying to think of what, actually technically this would be definitely not that. Alright. So if I was trying to place stuff down. There we go. So anyways, it's the looping and appending of a new, and I call this delta. So that's a single digit digit that changes, and then it goes through every iteration. So now you need to change each digit. So I don't know. It is like a loop of loops. I guess there's no. I'd like to think there's a way around doing a nested loop, but, and I know I could look it up on my Code Wars. Oh, oops, we need. Oh yeah, I guess I was gonna. Oh no. So there we go. So that'll prevent the water. I mean, but once you get that figured out, then you can just append the new digit onto the end. And digit's not really accurate because it makes it sound like it's a number, but the character, like the letter. No character. There we go. Putting the character in the far right space. And so what I was doing is using the string slicing of -1 to do the index of the last character and just change that one. So I'm targeting that one to change, and then checking to see, does this match, or is this your card? Is this your password? But hmm, yeah, I don't know. So that's where I'm at. But I mean, I still have tomorrow to work on it, I believe. Before the presentation, I don't know. It's very loose. Well, I'll explain that one day. But I mean, as it is, I think, and I think I'm gonna test this out before I go to bed tonight, but I already have it where it's targeting, the easy one is just all of the characters from 33 to 127, just a single digit one, and then, I'm trying to think of what that would be though, like, append it and check. A nested loop would do I could do a 2 digit, a 3 digit, or a no, a 3 character, or 4 character, just with like 4 or 5 nested loops, and basically what that would be is, you know, is this your card for all single digit? And then I think that's how you had to do it. There was a way that they actually wait. That's not quite right. It goes up one. There. Now I just need dirt, and I can actually do a couple layers. Oh, it's stuck in the whatever that is. Um, yes. Actually, so much effort just to get. Oh, I can't do that anymore. I have to go. Oh well. So I can already do this one. So I can pick up that stuff. This is really bothering me though. Like, because I've done it. I guess I mean, you won't know until you know. You're gonna go try like a 2 digit, 3 digit. It's hacky, but it'll do the job. The only thing that I'm worried about is like, if coding game will do it. Like, because that's gonna be iterating through a lot of potential passwords. Because it's brute forcing every single possible. I mean, alphanumeric, that's why I wanted. But even that, you have to target like, the 10 digits for 0 through 9. And then you have to target a second bracket, which I don't know. I feel like I'm making it more than it is, because I mean, even if we just did exactly what we said right there, it's like, oh wait, this is gonna, hmm, there we go. I think that's just, oh, I could do a little better. It still slopes. That kind of bothers me because if it's like a half a block, but it's cool because then you can see water. So it's kind of like a trade-off. Like you wouldn't even know from here, and I'm actually gonna block it off. So like I know just when I'm doing it, but I'm gonna do this, and then it's a non-issue. Okay. So, anyways, oh, and then the light every two. Close enough. Or actually, I think I did it. So, anyways, that's about. And I use kind of similar logic going through the letters and using 2 dictionaries for the ROT13 encryption and decryption. It cycles through the length of the word, and it takes each char, or each character, and it uses OR to get the number from the char. Be like, oh, this is a 33 or whatever, in which I think 33 is exclamation point, and 32 is space. And so I wasn't sure if space was like would be even a good idea to use, so I just kind of omitted it, did 33 and up. But yeah, but then the way using the dictionaries would be pretty painful doing a brute force because actually no, it wouldn't. That would be the way to show an alphanumeric, whereas a more complete brute forcing algorithm would include every single human readable char. Hmm. So I think I should go ahead and write a protocol, or no, not a protocol, prototype, a rough draft of nested loops from just awful looking code. So that's like if you're trying to find a choice, be like, if A, then this, else if B, then this. If C, if this, and like it's horribly painful. Oh, I didn't even use the. Oh well, non-issue. We just expanded our farming by quite a bit. Potentially. I mean, we still gotta chop down these trees, clear some room, or just go with this for now. I mean, we should at least do the right. Yeah, at every two. Wait, I blinked. I couldn't make it too easy. All right. So now, what should we grow? What watermelons? I know to show. So to do an alphanumeric check, it would just be nested while loops, and then, or no, and serialized. Actually, never mind. Because first you check a single digit, and then it would break out of that loop because it's not any of those options. So, huh. Actually, you could just increase the dictionary to have capital letters, and then be like, if this is in this dictionary, or even a list. Oh, wait. I'm trying not to do it too much because there's ways to just do like, hey, crack this password, or like, I mean, or guess this thing, or I don't know. There's already pre-built. I mean, using ord and char are okay because you're really trying to just find. I mean, in Java, there's ways. I think if you just like use the how to describe that. If you cast it as an int, if you cast a char to an int, I think it gets the. But I could be wrong. I don't think it's the ASCII value. I think it's, or maybe it is. I don't know. See, but you can add to it, and I think there's a way to do it that way, or do that, get the ASCII value. Even as I say that, I'm pretty sure every time I've done that, yeah, now I'm waffling back and forth. So, oh, look at that, the moon going into the temple, and the sun's gonna set into the temple. Oh, it's gonna be sick. All right, let's see. We got what? 3 minutes? Does the sun set in 3 minutes? I don't know. Let's stay here. Let's keep harvesting crops. We'll go ahead and break these to get. Oh, let's get rid of some of this stuff. Oh, this music hits hard. Just kidding. I feel like it's like a TikTok timer or something. Not TikTok, but like it's like a countdown timer for like a cleanup song or something. Or game show. Or like puzzle show. Alright, so we got sunrise. We might go a little over the 30 minutes in this one because I want to see the sunset. Although, how much is that? I wonder if it's like 5 minutes? So we're already at a minute and it's just barely sunrise. Let's see, you can almost tell the ratio like, so there's a 1, 2, 3 of those blocks. It's like a block per second. It's like rising up. And how many blocks are all the way in a 180 radius? Radian? Yeah, radian I think is the arc length, arc segment. Whew. Really twisting the old brain in knots on this one. Alright. We need to get watermelon seeds. For that we need to punch watermelon. Alright. Yeah, I think I have a good idea of how to do just the alphanumeric one, and then it'll be hacky, but then at least I'll have that in case it is tomorrow. And then I'll work on it tomorrow night and do a new iteration of a better algorithm that's more scalable. And actually I do that on the guide. I start with, um, it's the rot 13 with, or no, it's just basic rot 13, and then I do a rot n. So it's, change it by any index, and then reverse it by the proper index accordingly, because it can't be rot 14, because if you did it 14 every time, if you encrypted it and then decrypted it with 14, you'd have to decrypt it with a 12. I see 13 in a 26 letter alphabet, which is half of 26, is the only value that you can encrypt and decrypt using the same key. They're the same number. All right, wait, where are we at? Oh, it's almost 30 minutes, and it's almost, what was that? So it took almost 3 minutes to get about halfway. So we'll do like 33. All right. Well, yeah, because I don't want to cut this into two. Maybe I can fast forward it in the future, edit it, or just cut out the. I could clip it. That is a thing. I do need to go back and edit some of these videos. I feel kind of bad because I just like toss stuff up. There we go. There's the official alarm. It's not even to noon yet, so we'll be going a few minutes over. But anyways, no, it takes a lot of time. Like I was watching one YouTuber that's what she does. She's like a big time YouTuber. I'm still small time. Apologies, and it's not out of disrespect for you, the viewers. it's it's just out of my own bandwidth. Okay, so that's basically. I'm trying to think of like even just like saying the exact code. Like you have a while loop, and I put in that index is less than 100. Just to start off easy to make it only spit out 100 combination things. So, and then it would print out. I guess if you're just doing alphanumeric, you just first have to make a dictionary with all of the letters and numbers that you want to use, and then actually no, you could make a string, really, just a variable or a list. I mean, I already have a dictionary with all the lowercase letters, so I'd have to add one for all the uppercase letters. See, that's why it gets pretty cumbersome. That's why it's like kind of nicer to just use ASCII values, because then you're using a target and you're making them do it instead of typing out every single one, and you're just going through a range of numbers. So I think it would still be better to just do guess all of those, but then that's just for one digit, so that's not very useful. You need to be able to append a guess to a guess, and then that's why nested loops, you do the outer loop for the tens or the left digit of a two digit or the left character of a two character string or a string the size of two. There you go. That's a way to think of it. Um, I just put that right next to yeah. So this kind of end up missing. Make it explicitly get everything. So where's that sun? All right, we're doing it. I don't want to like go do anything too crazy, and it's like let's punch watermelons with seeds. Doesn't matter what. I think it breaks the same with everything. That's not a. I mean, this is the slowest. Like, see if I do this. Oh wait, that's a pumpkin. That would be this. Yeah, see. Plant the watermelon. Hmm. Sorry, this is like really boring. I do just want to see the sunset into the capture that. Ah, oh, man, already 3.5 minutes over. No, I gotta commit. Let's just keep talking the code. So you're cycling through, and you're guessing. So you have your guess, and you start off with whatever the lowest value is. So if we're doing the ASCII values, I think it's a zero. Oops, wait, wait. It starts out as zero, which is like 40 something. Um, Oddly enough, 42 is the ASCII value for a star, which in computer science is the wild card for everything. So to search all files or all this or all things that match pattern, that's the wild card. That's why I'm kind of a fan theory that I thought of. I didn't have anyone tell this to me, but I'm sure I'm not the only one to like draw that connection, especially if it was intended. But if the ASCII value is 42, and 42 is the meaning of life in Douglas Adams with The Hitchhiker's Guide to the Galaxy, uh, bada bing. That's a pretty cool, neat thing. And The Hitchhiker's Guide to the Galaxy, I think it was an old radio show. So it was back before the time of modern TVs, or at least TVs being a household commodity. It was more radio, like the time period the Christmas Story is set in, like I think it's Ralphie with his bunny pajamas. Anyways, my point is computers were around that time, but I want to say like 76. Oh, I should probably look this up. Like, and like the actual computer. I mean, like the original ones, Scott off like took up an entire room, do very basic calculations, and that's about it. And now, like we've all got phones that we can sit in the bathroom and just do massive calculations in the browser. Like, I mean, because it's not taking place on the phone, but it just tells someone to do something on their computer and then spits out the results. So that's also why I like to put that safeguard in to create or to prevent an infinite loop from happening. Alright, so actually we need to kind of go, we're going to need to figure out like a viewing place for this. And it has to actually be like here, or even closer actually. Oh, well, this is almost like too close. It looks off center for some reason. Like I can't like look directly at the sun. It's like, maybe like this? No, not back this way. I mean, it's almost there. Sorry, it's like justifying just sitting here chilling, waiting for a sun, and staring at a sun too. You never do this in real life. Don't ever look at the sun, ever, and don't look at an eclipse without proper eyewear. Always consult. Like that's you'll go blind. You literally will. I had 2010 plus one vision, and I try to never look at the sun, but it happens. I see reflections of it off windows. In fact, I see that all the time driving, and who knows how bad that's really damaging my eyes, but I know people that cannot see like that, and I don't know if it's due to sun or whatever. I mean, it's a range of things. Anyway, sorry, we're getting off on a tangent there, but this looks good. There's a viewing point, like more here, but I'm going to be adding like 4 more rows there, so it's going to be a little wider. Really just trying to center it. It needs to look smaller, because as it is, see, like it's going to fit right in the temple. Yeah, Jesus, that ended up being a long one. Sorry. Yeah, that's cool. All right, I'll keep working on that, but I mean, we waited this long. Let's see, it just settles in there. And maybe I could put like a curve thing. Oh, yeah, there you go. So, all right, I'll work on that. But first, I'm gonna go write that code. So, ta-ta. Have a good night, everybody. I will see you in the next one.